So actually, so what I thought of doing is, we are going very slowly. So we can discuss a little more. We can discuss few research papers. So we can, we will come to know, how to do research and all. So for that, I think we take a little more time. So I thought I'll take some special class, and then, because, after some time you will be busy with your minor works and all. So I thought I can take some class now so that we can finish one unit, so that you will be feeling comfortable, is what I felt. Okay, so I think nobody is there in this class with force. Am I correct? So you are by force you are here, or by your own interest you are here?
Interesting.
Okay. Cyber true. Okay. Yeah, so now let us go ahead. Yeah. Cyber is asking about recordings. Do you really need recordings of these lectures? Yeah, let us have an open discussion. Tell me
Yes, sir.
why.
Some of the students did miss their classes. Like some of the students were suffering from COVID, and they are sick really. So for them,
You are suffering from COVID.
yes, sir.
Huh? Oh, okay. So we can we can give you. It's not like that. We cannot give you the video lectures and all. But there are so many good lectures. Video lectures are available. There are so many books are available. So students of NIT Warangal. Okay. So they are capable of doing everything on their own. No. See, one thing you should be, attend the classes minimum and participate in discussion. It's not like you cannot read on your own. In my view, lecturing is just reduction of time. If one topic is introduced to you, instead of reading for 3 hours, you can grab it in 1 hour or half an hour. That's it. That is only the difference. Rest all the things are available. Okay. All right. So we'll try to know. I'm saying, I will not share my videos. And if you are in discussion, if you get any questions, definitely I'll be answering those. And possible, If I am going speed, you can ask me, to stop for some time, so we can discuss together. Okay, and okay, come out with a solution. So always writing notes is a good thing. And I'm seeing my son is third class. Right, he is having classes, and their teachers are not, they are, strictly instructing them to open their on their video and interacting, even though, I feel like they are not missing their offline classes. Right. So that's such in a way third class teacher is doing. Now I'm at BTech level. Okay. So why can't we do when the moment I ask questions, few will respond, we will not respond. Shame on our part. Third class student is studying. No, is repeating. It's not like that. Like what we are doing and all, I don't know. Okay. So if you are attentive in the class, you will be learning. One day you are missing your class. There are so many other videos are there. You please. So that's the way I feel. It's not like we can't give. It will become one more video. There are a number of videos are available in YouTube. Okay, better than my lecture. Okay, so that's what my Sai Varun, what do you say?
Yes, so we can learn from other sources, but there will be some coordination with if we listen to your lectures, no, sir. Like,
That will be there, no sir. See, today, one day you are not attending class. And today I will not attend class. What is there? Any of sir is giving a video lecture. No, I can listen those things and all in lateral time. You may feel. No? So regular students also may get mm, like a feeling in now no need to attend class. Driver,
sir, I didn't get you, sir. There was some
they,
disturbance.
they can get like that also, right? When video lectures are available, why to attend now class? We can see later only. Like that they can feel. No, ఏమంటావు?
Yes, sir, that's also true, sir. But there are some genuine students also, sir. Then we cannot.
If they are
Yes,
genuine students, let them attend. That is only the solution. Okay. If they are not, see, you are 180 strength. Now 74 are there. 100 students are missing. 100 are genuine. Tell me.
so
And all excuses, I will. Last 15 years, I'm seeing in the campus. Hey, okay. It's not like we cannot give, but thing is, that's what the truth. Okay. All right. I'm telling you, I will not give. You whatever the feedback you want to give to me. I don't care. Okay. One thing is, if you have any questions, if class is boring, you stop me. Correct, no? Or you teach, I listen. Should be there. Okay. Okay. don't be that much. But only thing is, really, I'm telling you, NIT Warangal is ranked top 8th when I joined in this institute. 2006, 7, it was top 8. Students prefer to join NIT Warangal rather than IIT Gauhati. But now, students used to prefer CSE EC branches in NIT Warangal than IIIT Hyderabad. Now, NIT, NIT Tiruchirappalli is ahead of us. NIT Surathkal is ahead of us in ranking. But we are 34 members faculty, largest strength among any NITs in India. Where should we? I'm telling you very clear. Students are regularly calling me and then asking me for recommendations. Sir, I'm applying for US university, so I want recommendation. Why should I give recommendation? Tell me. I ask the same question. You tell me one point from where the credentials of the students can be claimed by the department for ranking improvement. You join in NIT Warangal, fine. Right. So you just carried the reputation of the department and getting jobs. Remove the tag of NIT Warangal and get job on your own. Okay. So you are using college name and college reputation and everything. Okay. And you are getting job. Which way you are helping department to improve ranking? Tell me. Tell me one point. Not you, your seniors. So if teacher is lenient, is not taking care anything, simply giving marks and attendance and everything, then student will not be serious. I'm telling you, teacher is the only responsible person. If teacher genuinely fails the student will have a fear. He will afraid of, and then say like, yeah, I have to, no, I have to attend classes, I have to regular, otherwise I will be failing. And if you do some research work, not now, at least when you are in final year, is 180, at least out of 180, 90 papers if we get per year, our research improvement will be like anything and our rank will be somewhere else. Only thing is the lenience way which we are giving is carried out, and I don't want that to be a load. What for me? Today Saturday, holiday. I can enjoy with my son and then family, Why to take special class? Anybody forced me? Sai Varun, you asked me, like, sir, you want to take special class like that? You didn't ask me, no? I myself called you and then asked, like, I need a class.
Yes,
Right?
yes, sir.
Why? If I won't take class, I will not get my salary or what? Feeling responsibility. Yeah. Okay. So that's it. When the student feels responsible, today class is there. Yeah, we have to attend. So I'll show you the papers. I'll set in a paper such in a way that wherever you search in anywhere in the internet, you will not get answers. Okay. That is different story. Only feeling is when I feel like this is my department, this is my college. Right? So we are ahead, 8th rank, 25th rank, we are slipped. Why this is happening? Students are not serious. They are not contributing anything to the department. Zero. Okay. Internships. In summer, you can do internships, no? You will not do. Simply sit at home. All is there. Okay. Okay. I wasn't convinced that. Huh? I wasn't. It's convinced or still not convinced?
It's a kind of like, so like what you're telling is correct, sir, but there'll be many students who will be genuinely failing. So for them, we cannot just to punish the bad people. We cannot punish them also. That's what my point.
Correct. So who is speaking? Mangalpalli? Who is speaking?
Yes, sir.
I wasn't. You are. 170, 180 students we are. How many students are attending class? Do you know? Saivaran? Regularly? 90 are getting affected with COVID. Huh?
No, sir. Around I think like we'll be having
Hey,
students around that.
can I show you the class attendance of every day which I am taking up to now 3 weeks? Saivaran. No class. No class. I think initial 3 to 4 classes 120 plus. And after that, not more than 90. And see, I will give R grade for them. Wait. Hey, am I wrong? You just please discuss. Yeah, what is there? Huh? I think I never failed anybody in my career by putting personal grudge and all. I am not a candidate of that kind. Okay. Anybody, please respond. CR is Sai Varun, so that's why he will respond. No. 90 students are attending regular class, and 90 students they are not at all attending class. What should be done? All they are getting affected with COVID. Huh?
The total strength is 150. 50 members.
150.
Yes.
So then almost 40, not 40, 60 students are absent. Last 4-5 classes attendance you see. 60. It's not like there are no 70 or there. If today even a short span of 1-2 hours of there is a class is there. Yeah, I'm ready to take class at any moment. Now if you come to campus also, sir, at 9 o'clock class. Yeah. We used to spend time at night 9 o'clock to 12 o'clock in labs. You have to own like this is my department, my institute. I have to do something to the department, something to the institute like that. That is not there. Okay, all right. Okay, so right. Yeah, fine. So we had, sometimes a certain discussion should be there. You have to feel like, yes, whom I can approach in the department. Yeah, so there is a faculty. So we can share something. So, right. This is just, just discussing. Okay, all right. You have to write your own notes. I will not give you all these things. Okay. All right. So we discussed, we are discussing block diagram reduction technique. Okay, in block diagram reduction technique, which rule we discussed in the last class? I think rule number 4. I think blocks are in series, blocks are in cascade and all. So here, so arrows represent the direction of information or signal flow, and the rectangular representing the block usually contains a description of the name of the element or the symbol of the mathematical operation to be performed on the input. Okay, so the signal can be differentiated or integrated or added, or some the mathematical operation done on the signal is represented using block. Then three things are what we are discussing. So this is what we have done, right? Yeah. So where are in a given system, if there are two signals, if they are getting added up. Okay, there are two or more signals if they are getting added up. So this is signal A, and then this is signal B, and then this is signal C. So A and B are getting added up, and C is getting subtracted. So the signal which we get here is A plus B minus C. So what we can do sometimes for simplification purpose, we can split the summing point. Okay, we split the summing point. So when you split the summing point, right? So this summing point will be having a signal like this A and B. Okay, and there is one more summing point here. So here the signal which we getting is A plus B, and the signal is getting subtracted here, so that we will be getting the same signal A plus B minus C. So if there are three signals are getting summed up, then you can split that into two summing points. Is the rule is clear? Splitting the summing point. Is the rule is clear?
Yes, sir.
So then rule number 6. If you have a summing point like this, where you have signal A and signal B, and they are getting added up, And there is one more signal here like C. So you may be getting A plus B, right? And then minus C is what the signal you will be getting. A plus B minus C is what you will be getting here. So sometimes, you can interchange these two signals, no problem. If these two summing points are side by side, then you can do like this. So this is A, this is C. So here you will be getting A minus C, right? So this B point is what you can take up here. So here you will be getting A minus C plus B. So you will be getting A plus B minus C. Is that all right now?
Yes, sir.
Yes, sir. Then, rule number 7. If there is a block and there is a summing point, this is signal A is going through a block. Transfer function is G. So he will be getting here AG. So these two are getting added up here. One more signal is coming here, that is B. So here you will be getting AG plus B. So sometimes we have to move the summing point ahead of the block. What is the rule? Summing point ahead of the block. Okay. Right. So if you want to move it, no problem. This is A. So this is B. Summing point is what I moved up before the block. But what is the signal I will be getting here? Tell me.
AG plus BG.
So I will be getting AG plus BG. So I will be getting AG plus BG. But what should be the signal I should get?
AG plus B.
AG plus B. So what should I do?
B by G.
B by
Initially,
G.
1 by
So
G.
when I move the summing point ahead of the block, that will be multiplied with a gain of the block, which is of 1 by G. Okay. So I'll be getting here A plus B by G. So I'll be getting AG plus B. Okay. So this is rule number 7. Okay. Clear?
Clear.
Rule number 8. Now I have a summing point here. So this is A and this is B. I have a summing point here. So I have to move the summing point before the block. Tell me the rule.
Multiply with it block of G.
Add with BG.
What you have to do? When the moment you are moving a summing point before the block, you have to multiply that signal with the gain of the block. Okay. So here you will be getting AG plus BG. All right. Clear? Huh?
Yes, sir.
Yes, sir.
This is rule number 8. Rule number 9. So sometimes what we do, we will be having a system like this. We will be giving a feedback. The feedback can be negative feedback here. Okay, so here we will be getting a signal R. The output is controlled signal. This entire back. So this is called feedback. Earlier, what we have discussed is two blocks are in parallel, means two signals are getting added up. Okay, getting added up, right? That is not output is not fed back to input. That situation is different. Okay, same signal is diverted and then getting added up. That is parallel. But this is what output is fed back to the input and compared. Right. So now, what would go? This entire thing we can reduce into one block. So now let us try to do it. So the standard definition, this is called E, means error signal. Okay, reference. The signal which we feedback signal which we call it is called B. Right. So what is E? And this is
R
S.
minus B.
This S is what by default. So I'm just dropping this thing. Okay. So E is equal to what? R minus D. But what is B?
C into H of S.
C into H. Right. Okay. What is C?
E into G of S.
E into G. G of S. So I can write E is equal to R minus EGH. Right. So now, so C is equal to E into G, but E is equal to C is equal to, we have to bring the relationship of this C and R. C is equal to E into G. E is nothing but what? R minus CH into G. Okay. So C is equal to RG minus CGH. Now if I take C common, 1 plus GH. All right. So we have to get a ratio C by R is the transfer function. No. Clear? So E is equal to RG. So now C by R is equal to what? G by 1 plus GH. Is it not? Is it fine?
Yes, sir.
Yes, sir.
So when you eliminate feedback, okay, when you eliminate feedback, so what we will be getting? This entire block you can represent using one block. That is, you have R, and this entire thing you will be writing G by 1 plus GH. Okay. So this is G by 1 plus GH. This is G by 1 plus GH. This entire thing. So that means this entire block we can write G by 1 plus GH. This is elimination of feedback. So this is R and then this is C. So is this clear now? This entire thing we can replace using G by 1 plus GH. This is rule number 9. Understood?
Yes, sir.
Yeah. So now let us go ahead. Now reduce this complete block and then obtain the transfer function. Once you have transfer function, you can do further analysis. That is different story. Okay. So now
here we are taking the operational time as near to zero, no sir?
what do you mean by that?
Means like for suppose if we feed x to if we feed some input to the system, for getting the output it takes some time, no sir? In the feedback system we are getting the previous value, like what I'm trying to convey, I understand.
No, immediate. Yeah, whatever C is correct. Said is correct. Okay. Yeah. Operational time is 0 is what. The moment you are giving input, the moment you are giving input, you are getting output. Okay.
Yes,
All
sir.
right. Now, this is a control system is what represented using this block. Aishwarya, please mute your mic. Yeah. So now what we should do? There is no unique way you should follow like this, like this. Any way you can follow, but answer should be the same. Now, what should be done now?
Stepwise solving from left to right words.
So now these two blocks are in
Series combination.
series. So they can be written into one block G1, G4, correct?
Yes, sir.
Yes, sir.
Yes, sir.
And then these two blocks are in
Parallel.
which is G2 plus
Exactly. Sir,
G2 plus G3.
Yes,
Yeah.
can we directly write G2 plus G3, sir? Because we have middle add symbol. So can we directly write them?
See now, I let me redraw. So here you have one signal R, one summing point, and one more summing point. When you draw, I'm writing with freehand. Pen with me. It's not there. Okay, right. So then this G1, G4 is reduced into one block. We know the rule. So this is G1, G4. Okay. Right. And G1, G4, there is one more signal is getting fed back. Okay. So this is with the H1, right? So these two signals are getting added up. Okay. And these two blocks are in parallel. So we can write, instead of these two, we can write one. That is G2 plus G3. Okay. So here I am writing G2 plus G3. Okay. G2 plus G3. Right. And then there is one more feedback from here to here. H2 and then here. These two signals are getting subtracted, negative feedback. Now the same rule, if I try to apply, if this signal is getting added up here, what I should get? If it is minus, then
G by 1 minus GH will be getting
G by
if they
1.
are adding.
That's the rule. Okay. So up to this point is clear. Saurabh or somebody is asking previously one question. So can we write directly there? No. You have to go step by step, right? Vaibhav.
Yes, sir. It's clear.
So at this point is clear. No? Now what should be done next? Which rule is this? Which rule we can apply here?
Ninth rule.
Ninth rule, elimination of feedback. This completely can be written as, let's say
G1
this is GH. G by 1 plus GH. No, now tell me.
G1 G4 by 1 minus G1 G4 H1.
1 minus G1 G4 H1.
Sir, 1 plus, sir.
Why
No
1
sir,
plus?
Here both are added, so minus only.
Minus, na?
Yes, sir. Minus one.
Minus only, na? If it is minus, we are getting plus. If it is plus, rule G by 1 plus GH there. Here G by 1 minus GH because both are getting added up. Okay. So now this is, we will redraw, and this entire thing can be written as one block. That one block is G1 G4 by 1 G4 by 1 minus G1 G4 H1. Okay, right. So this entire thing, and then it is now in cascaded with G2 plus G3, G2 plus G3. From here there is a feedback. And now this has plus and minus, R reference, C control. Okay, huh? Now what should be done?
Like the inner two blocks are in series.
Series. So now that can be reduced into one. So G1, G4 multiplied by G2 plus G3 by 1 minus G1, G4, H1, right? And then there is a feedback. And this feedback, I think there is a one more block gain here. Na? Signal is getting modified. That is H2. Okay. So now this entire thing we can write into
Using 9
Single block
and
eliminated.
replace it.
so G by
Gain 3.
1 plus GH. So now tell me the modified, the final answer.
H2 by 1 plus G1 G4 H.
So it should be G1 G4 G1 G4 into G2 plus G3 by 1 minus G1 G4 H1, 1 minus G1 G4 H1 by 1 plus G1 G4 H2
Sir,
into
H2 should be at numerator, na sir.
why? Let us take this completely is G, this completely is H. What is the rule?
C by R must be H by 1 plus GH.
G by 1 plus GH, no ba?
Sorry.
Rule number 9.
Sorry.
G by 1 plus GH, no? Here it is only RG Garaba. C by R we are writing. It is G by 1 plus GH. Okay?
So, sorry, sir. Wrongly wrote.
Right. No problem. Right. So now this is G1, G4, H2 into G2 plus G3 by 1 minus G1, G4, H1. Correct only, no?
Yes, sir. It's
So
Yes,
what
sir.
you will get? G1, G4 into G2 plus G3 by 1 minus G1, G4, H1 plus
G1 G4 into H2 into G2 plus G3.
G2 plus G3. Correct only, no?
Yes, sir.
This is what the transfer function. So this is R, this is C. This is what the final transfer function is. Once you have final transfer function, you can do chapter number 2 analysis, chapter number 3 stability analysis. So few systems are available in complex domain like this. Then we will be doing these kind of things. So now, if anything is given, then you can do it. No.
Yes, sir.
So now this is a problem. The few terminology: open loop transfer function, feed forward transfer function, control ratio, feedback ratio, error ratio, closed loop transfer function. Now, just now what we did is what? Closed loop transfer function means C by R, no? Right?
Yes, sir.
So now coming to the open loop transfer function, K by S plus 1. So this is what the reduction. The open loop transfer function is, this is what the terminology. C of S by E of S is feed forward transfer function. Open loop transfer function is B of S by E of S. And you know what is B and what is E? No, I told you. Whatever you get here is what? B. Here is what? E, right? Error is R minus B, no?
Yes, sir.
So these are the terminology. Generally, it is followed. Feed forward transfer function C of S by E of S, which is G of S. And open loop transfer function B of S by E of S, which is G of S, H of S. So open loop transfer function. So this is what very important. Try to know the terminology, and while gate point of view also it is very important. Plus and minus, there are almost around 8 to 9 marks is what generally appears from control system subject. Gate examination. If you want to get any MN, what are the companies called? Public sector companies, government companies. If you want to go for government companies, like earlier, like HPCL, BPCL, or otherwise you have ECIL, you have PEL, Bharat Electronics Limited, and so few companies they will take based on gate examinations, right? So then gate score is important at that time, and 8 to 10 marks generally appear from control systems. Okay, and qualifying marks itself 26. It's very easy subject and scoring subjects too. So now this is G, this is H. So now this is C, this is R, standard notation, right? So this is B, this is E. So B by E. B by E is means what? This GH. G into H, loop transfer function, open loop transfer function or loop transfer function. Feed forward transfer function, C of S by E of S. It is called feed forward transfer function, C by E. Control ratio, C of S by R of S, which is G of S by 1 plus G of S H of S. Feedback ratio, B of S by R of S. B of S by R of S is what? Feedback ratio. Error ratio, E of S by R of S. Closed loop transfer function, C of S by R of S. Closed loop transfer function. Characteristic equation, 1 plus G of S H of S. If equate to 0, then it is called characteristic equation. Okay? All right. So now the terminology is clear, then you can go ahead with anything.
Sir, what's the difference between control ratio and closed loop transfer function?
One term is given here, otherwise it is same. Closed loop transfer function. Okay. Right. Closed loop transfer function only, the general term. Closed loop control ratio is what he is calling. It's not this thing. I never come across in my control terminology anywhere. Here he has given, I copied this problem from somewhere else. Right. So now these kind of questions may come in your minor examination. The system is represented by the following block diagram. Determine open loop transfer function, feed forward transfer function. Feed forward means here. Okay. Feedback ratio, error ratio, closed loop transfer function, characteristic. Okay. These are the things we have seen. Now, this is what the problem given. So can you do it? I think if it is there. Yeah. Now, what should be done? Tell me. From where to start, how to start? There are a number of ways you can do, no? Tell me. Yeah. You can move this branch point before the block. That you can do. Yeah. Someone can move this summing point ahead of the block. Yes or no?
Yes, sir.
So shall we do it? Now if I move this a branch point ahead of the block, what should be done? I can move it or not? Moving branch point before the block. What is the rule? What should come here? G3 or 1 by G3?
G3.
Sure.
1 by
G 1 by G3.
It's feedback, so it must be 1 by G3.
Fellow. The signal here is A, this is G, AG, no? So I'm moving it here. Okay, move it, who is stopping? This is G. The moment I move it here, what the signal I'll get?
We'll be getting AG.
AG, but what should be the signal we should get?
It should be A. So we will multiply with 1 by G.
1 by G.
So here we should multiply here by 1 by
G3.
G3. Okay, na? The moment I move it here, these two blocks are in.
They'll be in series.
Series.
Now these two blocks are in series, no? This can be one block, no? H1 by G3. Yes or no?
Sir.
Yes, sir.
So now, so what he has done? What he has done now here? Anyway, you can
This
do.
sum
I think he has moved this here, right?
he moved the summing point.
Oh,
The
summing.
summing point after G1.
Yeah. So summing point ahead of the block.
Yes,
So
sir.
this is also H2 by G1. Just now we discussed the rule, right? So this is
Yes,
H2
sir.
by G1, and then these two are in G1, G2. When it is moved, these two are in parallel, no? So these two are in series, right? So H2 by G1, G1, G2 are in series. Okay. And now
Now the feedback path, like G1, G2, H1 is the feedback for that thing. So he eliminated the feedback H1.
yeah, so it can be done this way or any way. There is no unique way, okay? All right. Shall we do it, or can you do it on your own? You can do it, no? Or you want me to do? So here, let me do it. So no answer means you are saying me to do. Okay. So there is a summing point. There is one more summing point here. Right. So this is G1. Now I'm directly writing G2, G3, they are multiplied. So G2, G3, they are multiplied. And before G2, G3, there is a summing point. Before G2, G3, there is a summing point. Uh, Here, this summing point is what I moved here. So this is H1 by G3. This is H1 by G3. This H1 by G3 is coming up here. So these two are plus, right? And now I can take a signal like here, same signal, no? I can take it from anywhere, no problem. H2. So this is H2 plus and minus. This is very important, right? There is one more signal which I am trying to take. Is there any difference now? Same signal, right? Here. Okay, so this is plus and minus. To avoid confusion, I'm taking the same signal differently. Okay. So this is plus and plus. This is H1 by G3. This is H1 by G3. So is this correct now? This is understood. This step is understood now. Okay.
Yes, sir.
So now what can be done? This entire block can be reduced into one block. No?
Yes, sir. We can eliminate the feedback H2.
So you can take it as G, you can take it as H. G by 1 plus GH, no?
Yes, sir. G by 1 plus GH.
So this will become one block, right?
Yes, sir. It would be
Then these
G2,
two are in
G3.
cascade. These two are in series, right?
Yes, sir.
Then you can eliminate this feedback, right?
Yes, sir.
Then we can eliminate this feedback, right?
Yes, sir.
Easy only, no? Now, uh, let us take a rule like this. Have one G, and then here you have like this. So this is R, and then this is C. What is the rule?
Mm, we can
H is 1.
replace it with H equals to 1. So G by 1 minus 1 plus G.
That's it. C by R is equal to G by 1 plus G. That's it. Okay.
Yes, sir.
So like that you have n number of problems. N number of problems. Then you can solve this. So take this as homework. So now సాయివరుణ్ నాకు పేపర్ పంపించావు కదా What is the name, Sai Varun, the file name which you sent me?
That textbook, sir.
Ah. Can you
Uh,
share once for me, Sai Varun?
yes, sir, sir. Sure.
Share
Automated
it once.
control system, sir. That is automatic
Can you
control.
share it? Can you share it me?
Yes, sir.
Share
Sure.
it here. Because so few problems you have to solve and make it ready. Not seeing it here. Can you share the screen?
So I had that textbook in my like laptop, like mobile, sir. So it's not in my laptop.
Okay, so you shared it me in WhatsApp on the day.
Yes, sir. I sent you in WhatsApp also just now.
So few problems you have to do. Let me give you as homework so that you can do it and practice. So you can see now, no?
Yes, sir.
Yes. So we are discussing chapter number 3. So chapter number 3, then the exercise problems you can take up. So this is page number 133. So 3.1, take the transfer function, the loop transfer function, forward path transfer function, error transfer function, feedback transfer function, closed loop transfer function. You can do it, no? 3.1.
Yes, sir.
Yeah, this 3.2 is what I have to explain. Okay, I can do it. Then 3.3 you can do it, no? It is the block diagram and find y by x.
Yes, sir.
So you have to solve it on your own and keep it your things ready. So this is 3.4. Okay.
Yes, sir.
So here what you have to do, G2, from G2 take two signals, G2 to H2, after that G2 to H1. Okay, there ends the matter. Fine. So 3, 4 also you do. So 3, 5, the aircraft turboprop engine shown in figure is controlled by closed loop system. Okay, so he is giving some practical problem, then do it, no problem. So we have to use MATLAB and then do these things. Okay, I will be explaining that in the next classes, coming classes. Okay, and yeah. So this is what the block diagram. Right. Find the following transfer functions. So aircraft, some kind of real-time situations they will be showing. You can solve these problems, right?
Yes, sir.
Yeah. So I have to explain, only one rule, that is the 10th rule. Let me explain and then we can take a break, no problem. If you are interested, I can show you few research papers. If you are interested, if time is there or some kind of thing, you can say. So one rule, that is rule number 10. Rule number 10. So sometimes, we need to do, there is a feedback, there is a feedback signal, but that feedback signal, what do you mean by that? Now let me explain this very clearly. This is R, this is C. We have signal which we are giving is feedback. Now, this full signal we can take and then give feedback. Sometimes fraction means some only signal is what we can try to take a feedback. So that signal is getting modification is what it is called edge. So sometimes we need to make, so it is called feedback system. What is the difference of this block and this block? Tell me. Diagram 1 and diagram 2. What is the difference?
The feedback in the second diagram is not modified.
It is fully, 100% feedback is given, right? Yes or no?
Yes, sir.
Yes, sir.
Yeah. So now sometimes, this kind of block diagram, if it is there, we have to convert that into unity feedback system. We'll be using this concept in second chapter, but here let us discuss this here as a rule. Right. So this diagram has to be modified into this is non-unity feedback system. This is non-unity feedback system. Here it is unity feedback system. So convert non-unity feedback system to unity feedback system. What you can do? Tell me an idea. This system has to be modified like this. But the same thing we have to get G by 1 plus GH, no? Got the point?
Yes.
Multiply with 1 by h
Where?
near h, sir.
Okay. So what happened? This is what the problem I am trying to solve. Here there is a problem number 32. So what is the problem number 32? Reduce the block diagram shown in figure 3p2 to unity feedback from and find the system characteristic equation. Okay. Yeah. So now somebody is saying, who is that? Who is where to multiply 1 by h? Correct. What you are saying is correct. Somebody said no.
Near b signal.
Near B signal, multiply 1 by h.
Yes, sir.
What happens? Means you mean to say here You mean to say 1 by h is what you are saying, huh? Well, if you multiply that by 1 by h, transfer function will not be same, no?
Sir, after G, if we multiply with 1 by H after G.
Okay, good. So now you mean to say here there is a G, and here you add one more block, which is 1 by h, and then like this, huh?
Yes, sir.
Now what is the transfer function?
Sir will convert using rule number 9, then again we'll multiply like one more system and cascade it. In series, we'll apply inverse of it.
So now see here, let us take this one. Do you get the same transfer function?
No,
G
sir.
by
No, sir.
h,
Output will be different.
huh? Tell me. Undu beta. So here what we are getting at? Okay, this is an idea. Okay. So this is G by h by 1 plus G by h. Correct, no?
Yes, sir.
So what we are getting? G by G plus h, no? But what we should get?
So can you go to the previous slide once? You should get.
G by
Taking
1 plus GH.
G by 1 plus GH is what you should get, no?
G plus 1.
Upon making that unity feedback, that's for sure. Okay, now if I multiply here by 1 by, or if I multiply here by h, not working, no? So now here, if I multiply here by 1 by h, then huh, we should get G by 1 plus GH, no? We are off the way.
Sir, can we take an extra G block before the summation?
Okay, huh?
Then I
We
think
take it here. We take it here G, huh?
yes, sir.
Okay, so when we take it here G, what we are getting?
And the second G block we can take that as 1 by G.
Here, huh?
Yes, sir.
Uh-huh. Take it off. What? 1 by G? Where? Here, huh?
just after G, instead of 1 by H, we can have 1 by 1 plus Hg minus G.
Okay.
Then I think we'll be getting G by 1 plus GH
So
for
think it of
transfer
now.
function.
So think it of now. A very simple rule. Okay, very simple. Right. So what you can do? Okay, you can do anyway. There is no unique way. So try. With that point, we'll be discussing in the next class. Okay. One more topic is there, that is signal flow graph. If we discuss signal flow graph, we'll be finishing first unit. Okay. If you have any questions up to this particular point, you can ask me, or otherwise, I can show you a few research papers by which you can do some research. So this is active vehicle suspension system, and on the day I think I would have downloaded. Okay, so this is suspension system of a car. Okay, so if you just type in so there is a paper available in IEEE Explore, appeared in 2009 by United Ritchie, I think, Pencon 2008. So this is a paper you have to download. You should have a subscription. So this DC motor speed control. If you just type research papers, or you can type IEEE Explore. That is a better way. This is how you can get the research papers here. Okay. There are 126. Nah. Yeah, so this is appeared in 2009 Chinese Control and Decision Conference. This is a very standard conference where you get your travel to fly. There is one more conference called American Control Conference. There also you get. There is one more called Indian Control Conference, ICC. These days it is happening in India. Okay. This is 2018. So people are still working on it. So like that you can download the research papers and then you can see, study other than your books. Okay. If you have any questions, you can ask me. But these are good journals only you have to take. IEEE Explore is what you try. Journal long faltu. From Iraq. So this is the motor. So key characteristics of the motor is what he is trying to take. Some studies history. Like that you can find. Yeah, if you have any questions, I'll be answering. So like that, we discuss mechanical system, we have discussed electrical system, electromechanical system. So like that, any physical system of your interest, you can model by using block diagram, and then somewhere you can get, and then we'll be doing analysis, stability analysis, and then designing up to controller. So you just make your system ready. So the books which you can follow is Benjamin Sekou, and then one more book which I told you, which follows very practical examples. I said one book, no, control system by Nice. Okay. There's also one more book which gives lots of practical examples. Okay. So if you have any questions, you can ask me, or otherwise we'll be leaving. Anything freely, because today is Sunday, this is not restricted to class. You can ask me anything.
Excuse me, sir.
Yeah.
Sir, how should we understand what is written in research papers? The language seems very complicated.
Hey, no, yeah, no. Only
Like
thing
the
is, yeah,
idea.
see, I think I changed my laptop, or otherwise I would have shown you different research papers here. Okay, somewhere if I can find, I think no, if you know it, the concept. If you don't know, then you find it is very difficult. Okay, so change my laptop. Otherwise, I would have everything. No papers here. Yeah, that's it. Slowly, once the concept is covered, definitely will be, understanding these things. It is not that much difficult. That's what my observation is. Okay. If you don't know the concept, it will become Greek and Latin. But if you know the concept, if you keep reading once, twice, you will be getting it very easily. Okay. I'll show you. I'll show you. No. Just now I have shown you a paper. Do you find this is difficult there? This is a paper. Okay. Comparative analysis of differential model based controllers using active vehicle suspension system appeared in 2000, which year? 19. Recent only. So he has given like this, some diagram. Okay. Right. Now, can't we model these things? So this is passive suspension and active suspension. one tire. One quarter means one tire. So here few equations are there. So I think can't you understand these equations now?
We can understand, sir.
Yeah. X
Sir,
dot.
but if we go through the abstract, there was few terms like ISMC and all. So we don't know those things, right? So
Yeah, slowly you'll be getting. Now you get matrix form, right?
yes, sir.
This matrix form in a state space model actually. I have to add to discuss. So here you may not be getting. So hold on. Okay. So when this active suspension system is there, we have to give a road bump. See, now this is suspension system. Now we need to design a controller. Slowly you will be understanding that you have to, a model and all, keep it ready. That's what I'm saying. So, this is what, if disturbance is like this, right? How will be, the vehicle, this is what road bump, right? This is what road bump, 0.06 meter. Is that true? Speed breaker would be 0.06 meter. Yes, no? And after some time, there is a, what is this called? Whole path. What we say? Inside air hole in the road. Then how the vehicle will, oscillate. We'll be doing slowly, we'll be doing, no problem. But you have to, at least try seeing. And there you will be referring few papers. By downloading those papers also, you will get an idea. Any other questions, please? Anything? Yes, we got time, that's why. If no questions, then I think we can leave now. It's 3 already. I won't give me time up to 3 only. Arshavardhan is there?
Sir,
No. The counterpart CRA led class law. Yeah, okay. Thank you. If you have any questions, you please ask me. Or otherwise, you will leave now. Okay?
sir, what could be the syllabus for minor one, sir? Like, uh,
Yeah, no, now I think 3 weeks over. Let me discuss for another 2 weeks, then I'll be letting you know. Okay?
so because I think from February 21st we have our mid examinations.
No problem.
So uh, I think we should conduct minors before 10th itself, so that
Somewhere around 10, I'll conduct. Okay?
okay.
It's a good scoring subject if you focus. Thank you.